It still, okay, it still amounts to about 70 points on the test. So
You're good to go.
okay, so we're gonna go, if you look at the formula page, and I'm looking on page 416. We covered the circles last week, and today we're extrapolating all the other stuff, all the triangles, the special right triangles, which I sort of like you to have, and the solid geometry. So I know this is going to be starting very slow, guys, so don't get bored. So triangles always add up to 180. So if we look at this one, we just fill in what we know because we're going to be doing some harder ones in a little bit. So every straight line is 180, so this is 100. And since triangles add up to 180 and we have 130, the missing triangle has to be 50. And we'll try one book one. It's my packet. Hold on. Because I've been looking for some harder ones for you guys. So let's look at 342, number 4. And I lost Daddy, but she's got to be there.
Yeah, she probably is. I don't think I can change the order, but I would like to be able to do that so that we, could,
Yeah.
but I won't. If you want to see her, you just have to hit that button. And then
Okay.
you can go back, but I want to keep you visible for the video.
Okay. So in 342, number 4, we have 52. So I know this is easy, guys. I'm going to assume everybody got D because you're all so bright. And also, what was I going to say? Oh, I did see on one test, they had 2 maxed out and they had the last one could be 1 degree. So a triangle could have 1 degree angle. So let's go on to the next page in the packet. And they can embed triangles. Okay, so for this one, if this is 40 and this is 120, that's 160. So this angle, you have to figure it out. So it'll have to be 20, because that makes this triangle 180. And then we're going to go up. That's going to be 30, 70. And so we have 140. So X has to be 40. And I'm sure you guys are all right with that. So looking down at this one, there is a theorem. There's no proofs on the test, so that's good. But there's a theorem, you don't have to know it, but it's that the exterior angle of a triangle always equals the 2 remote interior angles. So here, y would equal these 2, which are the same, and these 2, which are the same. So our answer would be 2y. But if I didn't remember that theorem, I could say, okay, y is 100. Picking numbers works here. You just have to be consistent. So this would be 80. These are equally going to split 100. So they're 50, 50, 50, 50. And of course, this would be 80. And so again, we would get 2y because 2 times 100. So you can either pick numbers or employ that theorem. It doesn't matter. So is everybody good with that? Let me just go down the line. Anish, you're good?
Yeah.
Okay, good. And I'm going to move myself down so I can see Addie.
What you do is you push that.
I push what?
She's nodding.
Okay. Addie's good. Sahana, you're good?
Yeah.
Zoe Robson
Yeah.
and Zoe Latham.
Yeah.
Good. Okay, let's go down to this one. So the next thing is they don't give you this, but the exterior angles of a triangle equal 360. So we're just doing what you might see on the test. So here, if Z is 40, this would be 140. And we're trying to get X plus Y. So we could just do 360 minus 140, and we get 220. If I forgot about the 360 thing, then I could say, okay, if this is 40, let's just say this is 120. And so this has to be 60. So this has to be 80. So this has to be 100. And I would still get 220. You just have to keep within the rules that a triangle adds up to 180. Okay, so let's try this one. So we're doing Y plus Z. So we know they all add up to 360. So I subtract the 125. And I will get 235. Okay, now they like hexagons because a hexagon can be, I know my lines are crooked, forgive me, can be made into 6 equilateral triangles. So we could do the 360 divided by 6. This was just sort of the purpose here is to get you used to hexagons. So I could do, this whole thing has to be 360, so this has to be 60. So they all have to be 60. Or, and we'll get to the other thing in a minute about the n minus 2 times 180. So if you have a question, just shout out. I'm right here.
So that one was just C, I guess.
Oh yeah, I'm sorry, that was C. Now the triangle proportion they've taken off the test. It just means the longest side is opposite the longest angle, but I guess they thought that was too easy. And so they're not testing it. They're also now not testing the triangle inequality theorem. Okay. So we're going all the way to here. So the 3 triangles that pop up all the time are equilateral. All the sides are the same. And like I said, they like hexagons. Isosceles because the angles opposite are equal. And then the Pythagorean theorem where the c squared, where a squared plus b squared is c squared. And they give you that on the formula page. All right, so let's go through some easy identifications. So this would be equilateral. I mean, we're covering a lot of geometry and all the sides would be 6. Now this one looks like you can't assume it's 90 unless you see this sign or they say it's a square. So we can see 50 and 50. This is isosceles. This side is 4. The other side, XY, has to be 4. And this one, they don't actually ask you for this, but this is scalene. And so the sides of ABD, now you might say, Mrs. Hessler, what were you smoking? That's not a 105-degree angle. But I covered myself by saying it's not drawn to scale. So this will be 30. And even though it doesn't look like it, the shortest side is opposite the shorter angle. So AD would be my shortest side, then BD, and then my longest side, even though it doesn't look like it, would be AB. So when you see this disclaimer, that's something to know you can't trust your eyes. Okay, so now we're going to triangle area and perimeter. And you know the area of a triangle is 1/2 base times height. Thank you. And the perimeter is you just add up as you go all around. So let's look at these. So this area, and usually students forget to take the 1/2. So this would just be 24. 1/2 of 4 times 10 is 20. Sometimes, and this is just to get you ready for further questions, the altitude is outside the triangle on an obtuse triangle. So here, the area would be 1/2 of 6 or 3. Now this one I'm going to enlarge, and I know we're going to cover these triangles in depth. We started with them last week a little bit. So here, we have to drop in altitude. They don't say clue, draw a line. And we're going to go over these 30, 60. So this will be 30 and this will be 30. And so then opposite the 30 is X, or in this 8 would be 2X. So this would be, this whole thing is 8. X would be 4. And opposite the 60 would be 4 square root of 3. And don't have any consternation because we're going to go through this whole triangle thing in a minute. I don't know when you had geometry, so we're going to be doing 1/2 times the whole base, which is 8, times the altitude, which is 4 square root of 3, and that'll be 16 square root of 3. Now I know we're just getting our big toe in the water here, so just tell me if you're sort of okay with it. So now what do I do to get Addie to see Addie? Addie, are you okay, hon? Okay, Inish,
Yeah.
Sehana,
Yeah.
Zoe Robson,
Yeah.
and Zoe Latham.
Yeah.
That's so funny. Okay, that's great. Okay. Now, there was a formula you had in geometry. So if you have a regular polygon, the formula is n minus 2 times 180. So here we have the famous hexagon. So if we put 6 minus 2 times 180, that would be 4 times 180, which is 720. And then I'm dividing it into its interior angles, which is 120. And so X would be 60. But I also could make like a Ferris wheel here. This would be 360. And so all the sides would be 60. So this formula is just like an extra feather in your cap. But you really just divide the triangle or the figure, the regular polygon. All they usually deal with is regular polygons. And then you just divide it into its, whoa, okay. Okay. So now similar triangles, there's a big emphasis on this now. More than there was ever before. And that's why we scooped up this hard problem I'm going to do in a second. We'll try some easy ones first. So the sides are going to be in ratio. So when they're similar, they have the same shape, but not the same size. The same size would be congruent, right? Sorry for the mess. Congruent is equal. So this will be 3 is to 9 is 5 is to. We're multiplying everything by 3. 6 would be 18. And so then we would just, to get the perimeter, we would just add this all up. And we would get 42. So I'd like to try a couple book ones, and then one that I got off, Jimmy scarfed it up, new problem released by the College Board. So let's first go to 425, number 10. we might get into some SOHCAHTOA early here. I'm not sure. And this one, I actually can't understand. It's in the module 2, pretty deep. So we know that X Y, Z is similar to, and they tell us, so R, S, T respectively. And we know that this is double the size, but that does not change the angles. So that's what so the angles don't change in a similar triangle. So I don't want you to get duped by that. So if Z is 20, then we're trying to get T, and so T will also be 20. So the fact that the sides are twice as big doesn't affect the angles. So is everybody good with that? Anish?
Yeah.
Zoe Latham?
Yeah.
Okay, Zoe Robson,
Yeah.
Sehana,
Yeah.
and then let's see, Addie. Oops,
That's not good.
that's not good, whatever I just did.
Yeah, hold on.
Sorry.
So to see her, you do that, and then you can see her, so she's.
Okay. You good, Addie? Okay.
Okay, but now I gotta fix the whiteboard.
Okay.
Hopefully I can.
Oh, I messed things up. Okay.
Yeah, it's back.
Okay, so let's try one more of those and then I'm gonna give you the hard problem. So we're gonna go to page 575, number 21. And again, it just helps me to draw it. And I guess you're all familiar with SOHCAHTOA, right? I'm assuming that. Better try this. And
You
even,
don't know that.
well, we don't know that that's
Yeah,
20, but we
so-
can sort of assume that,
No, it's not.
okay. So we want the tangent of W, which is right here, which would be
The tangent of T, right?
the tangent of T, which is opposite over adjacent. That's not going to change. And then we have to reduce it because we can see, so we're going to divide by 4 and we'll get 5/12, which is answer choice B. So we took it up just a step. So let me see. Addie, you're good? I can't see her. Sorry. Addie, you good with that one, hon? Inish?
Yeah.
Zoe Robson?
Yeah.
Zoe Latham?
Yeah.
And Sehana?
Yeah.
Okay, now Jim scarfed up these hard problems, which I think because the College Board, I think my theory is, I don't know it's true, is that they're having
Too many 800s.
too many 800s.
Right.
I don't know. So if you have a clean piece of paper, we're gonna just segue.
Yeah, write out the whole problem because they don't have it.
Yeah, I know you don't have this problem. We just got it off the internet. Like,
But it's a real College Board problem.
yes, a real College Board problem. So if you have a clean piece of paper nearby. Okay, it's figure not drawn to scale.
So it made that into it. I hope that's a C.
Yeah, this is a C, sorry. Okay, and the figure's not drawn to scale. So here's what they give you. In the figure above, well, I'll write
You can
that.
you just write what it is.
Yeah, AD equals, and this was a real hard one, obviously. So AD is 121/3. And AB is 11/130 all over 3.
So 11 square root of 130.
Let me write
all
that
over
neater. Yeah, let me write it neater. I'm so sorry. So it's hard to write on this board, I know. AD equals,
That's
One.
AB.
sorry, yeah. AB is 121.
No. AB is 11 square roots of 130 over 3.
Yeah. 11 square roots of 130 all over 3. It's a 3.
That's fine. Oh,
I'll write them out here. So AB is and if you can start to do it, I'm going to get you a little bit set up. They only give you two things.
and what are you solving for?
And we're trying to find
Maybe just put a question mark where it is.
what is DC. That little line there. Okay, this is as hard as it gets.
Give them a minute to try it. I'm curious, but I bet someone in here can get it.
Okay, we'll see if anybody can get it. It's similar triangles. Don't try. I tried using the Pythagorean theorem and it was a dead end. So try using similar triangles because you have two right triangles and by angle, they're similar. So you can conclude that. So take a minute and try it. My little ratio was AB is to the big hypotenuse as AD is to its related hypotenuse, which is AB. So if you put the numbers in and see if anybody can get an answer. I didn't do this with my regular group, but this group is going, speaking of Olympics, going for the gold, so. I'm just calling this the big hypotenuse on the bottom because we're going to have to find it and then subtract CD. But this, they love these similar triangles, it seems, lately. They didn't have them on as much before. Because they just set out this problem. We don't know if that's gonna be a signature on the test or not. My problem was I started to try to use the Pythagorean theorem and it didn't help me.
Could you put an A there just so that they know that that's A?
Yeah. Like I said, we didn't do this on Sunday. We look up special problems for you guys. That's at times. So I can multiply by the reciprocal here.
So you're just taking AC minus AD to figure out what DC
Yes.
is?
So I'm doing, yeah, I should write this down.
Yeah,
So I'm getting the big hypotenuse, so AC minus AD is gonna give us DC. And if you
did
get,
anybody get 3?
did anybody get 3? Anish, did you get 3?
I didn't finish yet.
Okay, go ahead. Say, Hannah, did you get 3? She's
Still working on it.
Still working, okay, I went to,
Just leave it up for them.
yeah, this
We
is
thought
just,
that was pretty hard for a similar triangle question.
yeah. And they're heavily, similar triangle, you will see some. They're heavily stressing that now. I don't know why, but this is a hard one, you can see. And if you started to do the Pythagorean theorem, I guess
They
you,
probably, yeah, you could probably solve this a few different ways, but
Yeah.
I like Mrs. Hessler's approach. It's pretty straightforward.
it's just doing this ratio right here.
Right. I think and also just realizing if you cut a right triangle like that, you realize that you're making similar triangles.
Yes. Leg over hypotenuse equals leg over hypotenuse. I'll explain it in a minute, but I want to see if anybody got 3. And when you get a nice integer answer, you should get a nice warm fuzzy feeling. So we're gonna bring in like some harder problems, these problems that Jim found that were on recent tests. But I want to be sure you can digest this one. It looks hard, especially because I started trying to use the Pythagorean theorem and I wound up with very messy numbers. And it was a lot easier to just do the ratio because they were similar triangles. So Zoe Latham, do you sort of get it or how are you doing?
I'm almost there.
Okay, good. Because if you get one of these,
Yeah, even if you want to sleep on it. But I
yeah,
guess they're putting some harder similar triangle questions on there, so.
yeah, that's why
That's
that's why we're trying to beef you guys up for the perfect score, actually. So this would be definitely module 2 at the end. So Anish, how are you coming? He's still thinking.
Yeah, I got 3.
You got,
you got 3?
Yeah.
Oh, cool.
did you do it the same way I did with ratios?
I did the Pythagorean theorem.
Oh,
Oh,
okay.
nice. So now we know it works both ways. It would
Yeah.
have to, you know,
Yeah. Sehana, are you good?
Yeah, I just got 3. I did the ratios.
Yeah, I think the ratios are easier. And Zoe Robson, how are you coming?
I'm good. I did the ratios too.
Yeah, I think it's easier. Ines, did you get some complicated numbers with the Pythagorean theorem, or they weren't too bad?
They're a little complicated, but they weren't
Yeah.
that bad.
Okay. Okay, good. So we're, like I said, we're gonna be putting some harder questions in, not to be mean, but because we know what it's like. You guys need a harder routine than the other kids, because you know your goal. Okay, so let's go back to the packet. We conquered similar triangles, even a hard one. Now we're moving on to the Pythagorean theorem, which is a squared plus b squared equals c squared. And so if we look at this question, we have to draw a line or we can't solve it because we have to get x, which is down here. So I'm just going to do 6 squared plus 8 squared. We know that's going to equal 9 squared plus x squared. So that's 36 plus 64. So that's going to be 100. And we subtract the 81. And I'm going to get 19 equals x squared. So x is going to be the square root of 19, which is answer choice B. So, Inish, you're good?
Yeah.
Sehana?
Yeah.
Okay, Zoe Robson
Yeah.
and Zoe Latham.
Yeah.
And we have to move to see Addie.
Oh, yeah, I can show her. There she is.
Addie, you can just nod your head. Okay, good, honey. All right. Now we're going to do this one. And I hope you have a calculator nearby, or you could use Desmos, I guess. I don't know. So this is doing the Pythagorean theorem twice, which would be a harder problem. So I have a 50-foot ladder. And it's against a vertical wall. And the bottom of the ladder is 14 feet from the base. So that's assuming a right triangle, and the height, we don't know. And we have a guy going up here to paint. Here's his little bucket. I'm sorry, I'm trying to make math fun. So the ladder's going to slip down. This would probably be a module 2, right? Jim, you think? And
Yeah.
so there goes his pail and all his paint. But he's not hurt. Well, maybe let's put him on the ground. But he's not, he's all right. So the ladder slips down 8 feet. And we want to figure out from 14. So as it juts out, this is going to be longer.
So 14 plus x or something.
Yeah. So what I'd like you to do is figure out what h is first, then plug that in for h minus 8, and then find the base and subtract 14. So take a few minutes and use your calculator. Was that you or me?
That was me.
Okay. Is that right? 2, 3, or 4? I
Yeah.
think so.
The square root of that is 48.
Yeah, I know. Okay, so I'll dive in here. So we're gonna do 8 squared plus 14 squared is 50 squared. 196 from 2,500 is 2,304. Square root of that is gonna be 48. So that makes sense. It's gonna drop 8 feet, so it's gonna drop to 40. And in a minute, we're gonna do something called a 3, 4, 5 triangle. Because if that's at your mental fingertips, you don't have to struggle through the Pythagorean theorem, which would be 30 squared plus 40 squared is 50 squared. So this base is 30. So 30 minus the 14, the answer is D 16. So take a minute and see how far you got on that. So Ines, are you okay?
Yeah.
Yeah. Addie, are you good? Yes. Zoe Latham,
I'm good.
Sehana,
Yeah.
and Zoe Robson.
Yeah.
Good. Okay, we're gonna try a book one, and this entails work with rats, taking it up a little bit, a higher level. So it's definitely in module 2. So we're doing page 424, number 8. And if it helps you to draw the triangle, it helps me to draw it, I guess. And I'll let you try to take it home. This is a little harder because you don't have answer choices to pick from.
That's 576. And 21 squared is 441.
So together that adds up to
1017.
oops. I'm just gonna do this prime factoring because it's easier for me to reduce, because I can't see the perfect square hiding in there at all. So I know it's 8 times 3. And then I know I'm adding. Because at the end, I'm taking the square root of this. So that's gonna be the square root of 24. Plus this will be 7 times 7 times 3 times 3. And so I can take out a pair of 3s, and that'll give me 3 times, because I'm taking out these two threes too, and I will get 113, which means this was divisible by 9, but I couldn't see it right away. Now it's pretty easy to see.
Could you also show it the sort of way I like to do it? So when you get here, that's equal to 9D.
Okay. Oh,
And then you just divide by 9 and you'll still get 113. Just a 10,
Oh.
1017 over 9 is 113 as
yeah,
well.
that's pretty easy, because then you know you're taking out a square, you're taking the square root of this eventually, right? And that's how you get the 3.
No, because that's just what D is. Because I squared it. Because you squared in that step.
Yeah,
So 3 square root of D squared is just 9D.
okay.
Yeah. So I don't know. I mean, either way.
So you got to ask a question if you're confused. Let's see. So this equals 9D, but then I have to take the square root of this, right?
No. You just divide 1017 by the 9 and you solve for D.
Okay. You just had to realize that you had to square that.
Yeah, if you square 3 square roots of D, you'll get 9D. Because you have to square the square root of D, so the square root goes away,
Yeah,
and then you get 9D, yeah.
and that way you can see the perfect square that's hiding in that. Okay, so Zoe Robson, did you get 113?
Yes.
Oh, good, that was a push. Sehana,
Yes.
Zoe Latham.
Yeah.
Oh, good, I'm so glad it's a bright group. Inish,
Yeah.
okay, and let me see Addie.
Oh, yeah.
Okay, nod your head, Eddie, if you're okay. Oh, good. So this is like Peloton geometry, so. Okay, we're gonna move on, but that was a good exercise there. In some hard ones. So now, back to the packet. I especially want to expose you to hard ones. So they don't give you this 3, 4, 5, but you've heard of it in school and the numbers just work out so pretty. You could have also 6, 8, 10, and 9, 12, 15. Also 5, 12, 13 work. Multiples would be this. Now, here are the ones that they give you in the book. But this is pretty easy because X and X, and we've seen this in a circle, right? As the as this is the center. And they can also do it as the diagonal of a square. So you can see the sides opposite the 45 are equal. And that this is a little longer because the square root of 2 is about 1.7, 1.4, I think. Maybe 1.4. It's a little bit more.
1.4, yeah.
Yeah. Okay. Then the 30, 60, 90. So since they give you these two triangles, and even on the ACT, this will be fair game, Zoe. So the 30 is opposite the X, opposite the 60 is X squared root of 3, and opposite the 90 is the 2X. So let's go on. And what I want you to do, just to firm it in your brain, is put these labels on this 30, 60, 90 right triangle. If you need to look at the book formula, you can, but you won't have it on the ACT. And this would be in the hard zone on the ACT too. But I just sort of want you to have this committed to memory. So if they give you a triangle where one side is half the, one side is half the other, you know it has to be half the hypotenuse in a right triangle situation. You know it has to be 30, 60, 90. So let's move on here. We're just going to fill out this chart. So if the short leg is 2, the long leg will be 2 square roots of 3, and the hypotenuse will be 4. And so I would like you to just fill out the rest of this chart. Okay, so see if your chart matches mine. Oh, this last one was the hard one because you have to multiply by the square root of 3 to go this way. So you're going to have to divide by the square root of 3 to go that way. Okay, so the last thing is, can you put these right designations on this triangle? Okay, so I'm assuming everybody's okay. Let's try a couple book ones. So first, page 296. We're going to try number 5, which is pretty easy, actually. They didn't even rationalize the answer.
That's lazy. Wow.
Oops. I want to get a right triangle here.
I would be looking for the square root of 3, and it's not even a choice.
Yeah.
It's silly they didn't rationalize it.
Okay, let me just go through this. Zoe Robson, are you good?
Yes.
Oh, good. Sehana,
Yeah.
Zoe Latham,
Yeah.
Anish?
Yeah.
Okay, good. And can we just see Eddie?
Oh, sure.
You're my fingers to see Eddie. Eddie, you nod your head, yes? Okay, we're gonna go to the next page, 298. And we're gonna try 11 and 12. Oh, I can't, once it does this, I can't.
10/26.
Yeah, but I'm gonna
We'll just
put,
put it 10/26 there, then you'll use the right numbers.
they give you 5/13.
I know, but it's 10/26 because it's,
I know.
yeah, and now you know where that 26 is, so you know where the 10
Yes.
goes.
Okay, so say, Hannah, are you good with 24?
Mm-hmm.
Oh, good. Zoe Latham
Yeah.
and Zoe Robson
Yeah.
and Inish.
Yeah.
I feel like I'm coaching gold
I'm gonna see,
athletes. I need to see Eddie. Eddie, you're good? Okay, good. So now we're gonna do 298, number 12. Since they put them in the book, we figure it's fair game.
they don't normally say hint, draw a line, but you might want to draw a line every now and then.
Yeah. The sine and the cosine always have to be 1 or under, right? Because of the curve, the sine curve never goes above.
Yeah,
Yeah. Okay, so basically, this one you had to draw the line. Then this was divided into X and X, 16 and 16. And so we didn't really have to do more than that. We didn't have to get the height. But so the cosine of X would be adjacent, which is 16/24. You wouldn't get credit for writing that. You have to put 2/3 0.666.
actually 4 6s and that,
Oh, 4 sixes?
yeah,
Really?
yeah, well, put 3 6s and a 7. Now, here's the interesting thing. Let's say you started with 0, you can actually, you don't have to go as far.
Okay,
They would accept 0.666 or 0.667. It's just a quirk of the new blue book. They consider 0 to be a decimal, so they say round or truncate at the 4th digit now.
okay, so Inish, are you good with 2/3?
For question 12 on 298,
Yeah,
I got 3/4.
Maybe I did it. Let's see.
no, I got 2/3.
Okay, so
Well,
we're,
ask everybody else, and then we'll figure out what you did.
so we're doing adjacent, which is 16, right?
Yeah.
And we're gonna be dividing it by 8.
Oh. Oh, on question 12,
Yes,
I had 24 and 32.
okay, but we have to draw this line
Yeah, you must have made an error.
because we're trying to find X. Does that make sense? So I had to divide this into two triangles. The 32 wouldn't help me. Because I have to get,
You need right triangles to use the SOHCAHTOA.
I need to get the adjacent angle. Does that make sense?
Oh, all right. I was thinking that the top was a right angle, but it's not.
Yeah, it's not.
It's not, yeah. And even if it was, it's not gonna help you to get this, you have to divide this by two. And the whole start of this was to draw this line, and they
And
don't,
they don't say, you know,
yeah.
hint, draw a line. See if everyone else is good with it, because that one was, maybe it was, you think
Oh,
that
that
was
was a little
hard?
hard. Addie, are you good with that one, hun? Good, Zoe Latham,
Yeah.
Zoe Robson,
Yeah.
and Sahana, you good?
Yep.
Okay. All right, that was a great exercise. So now let's go to back to the packet. I'm sorry, we're jumping around. We don't, I mean, it isn't that bad.
No.
Okay, we're gonna try these three. So this one, you have to be ready to orient yourself to different things. So this is our right angle. Now this, they do tell us, Sinish, that that's 90. So 7, 7, and this would be 7 square roots of 2. Thank you.
I just want to get it all.
I know. So we'll be doing 7 square roots of 2, because we want the area of the square. We don't want the perimeter, so always check yourself. So we multiply the 7s, 49, square root of 4, which is 2. And we're gonna get 98 for the area of the square. So that's not so bad. So number 2 is a workout on the 3, 4, 5. So this would be the 3 times, wait, I gotta write this so you can see. So this would be 3 times 3. This would be 3 times 5. So we know this has to be 3 times 4, or 12. And this would be 4 times 4, or 16. So this would be 4 times 5. Whoops, which is 20. And I didn't have to use the Pythagorean theorem. So just a heads up to look for a 3, 4, 5 triangles. Everybody good? I'm assuming you are. Okay. This one,
This is another draw a line type thing.
this is another drawn line, and you could see this because they can't do that much on the test, but they could do something like this. So if I drop this altitude, that's 90. 30, this would be 90, this would be 60. And 105 minus 60, I'm just trying to give you some harder ones. So this would be 45, this would be 45. So if 8 is my 2x opposite the 60, we don't really need it, would be 4 square roots of 3. But this height would be 4. I'm going to draw this triangle out. So this is 45. This is 45. So this would be 4, 4, 4 square roots of 2. And we crack that by drawing a line. Otherwise, I mean, you probably could use the law of sines or something on this, but it still would be very hard. Okay, so I'm going to ask you guys about this one. So, Zoe Robson, are you okay with this hard one?
Yeah.
Oh, good. Sehana?
Yep.
Oh, good. Zoe Latham?
Yeah.
Anish?
Yeah.
Okay, we want one of those college board, you could drop it on them on into August, and we have to see. Addie, you're good, honey? Nod your head, okay. You guys have such perfect attendance and everything. So now, okay, I want you to pick any 5. and just try these triangle problems. It's just sort of like a little workout, like a training exercise. And we'll give you a few minutes to do it, and then all we have is trig and solid geometry. I'm gonna go over them all. I just wanted you to pick 5. Because we try to get every kind of question you might get.
That's a minus sign, right? Mhm.
Yeah. Should I do this one?
Which one?
Number 10.
Sure. You just tell them the, challenge question or whatever. That's it.
Well, hopefully you did 5. And so we're gonna go over all of them. And the method to this is the hardest thing is if you get presented with some triangle problem and you don't have a clue how to start it. So you just fill in what you know, but I wanted to expose you to a bunch. So if you did number 1, A plus B is 90. C plus D plus E is 180. So I add these together, I get 270. I'm dividing by 5 angles. So the answer, if you tried this one, was 54. Does anybody have a question on this? We're going to get into the data and statistics lesson where we're going to be doing average, standard deviation, and all that right before your test. Okay, so the next one, we could just use the good old Pythagorean theorem. So we have to get the area of the square. All we know is the hypotenuse. Yes, we could say that's 6 divided by the square root of 2. And then multiply those out and get 18. Or we could just do x squared plus x squared. 2x squared is 36, so x squared is 18, and that'll be the area of the square. And then we'll do 3 at a time, and then I'll ask. So I did this one because sometimes they do steps, and it's important to know that this area equals these 3, or it could be the same thing vertically. So here, if the whole length of the bottom is 9, and this is 5, that would result in this little bit being 4, because the whole bottom is 9. Like if they gave you stairs, it'd be the same thing. And then this is 8. This would be 5, and then this would be 3. And right away, you should think, oh, I have a 3, 4, 5 right triangle. And then I added up all these, and I got 32. So on the first 3, even though you didn't try them all, Zoe Robson, are you good on the first 3 as far as feeling empowered to do them?
Yeah.
Good, Zoe Latham.
Yeah.
Okay, Sehana,
Yeah.
good, Anish,
Yeah.
good, and Addie, nodding your head, yes, good, sweetheart, okay. All right, so now, this one would definitely be a difficulty at the end of the test.
So the whole left part of that figure that's just there to confuse you.
Yeah, this.
You don't need it at all.
You don't need this part. You might have tried, I mean, it would be, you could use it, but you don't really need it. So I focused on this because my job was to get DE, which is that hypotenuse. And so if I have a right triangle and that's 30, that has to be 60. So they gave me 8 square roots of 3. So that's my 2x. Then my x is going to be 4 square roots of 3. And because usually you think opposite the 60, the answer has to have the square root of 3, but it doesn't. Because you're doing 4 square roots of 3 times the square root of 3, and that'll be 4 times 3 or 12. So let me ask everybody, since that was a module 2. Anisha, you good on that one?
Yeah.
Good. Zoe Latham.
Yeah.
Sehana
Yeah.
and Zoe Robson
Yeah.
and Addie. Yes. Okay, I feel like since I've been watching some Olympics, I feel like I'm saying, okay, do a triple backflip off the pommel horse. And you guys always do it. So anyway, but I'm exposing you to harder things because I mean, you're gonna get a lot of easy geometry too. This one we did last week in the book, if you remember, because I didn't know whether to do circles or, so we're just gonna review this. So if this is 60, and I know opposite the 30 is x, then opposite the 60 is 6 square roots of 3. So I get the area of the triangle, which is 1/2 36 times the square root of 3, which is 18 square roots of 3. And then I want the shaded part, so I have to take off what fraction of the circle? I have to take off a 1/6 of the fraction, which would be 1/6 pi times 6 squared. And so we did this one last week in the book, and then here it was in our packet. So I'm not going to belabor that. And then this one on the next page. Okay, I'm just looking at a whole, we just tried to give you a workout. Okay, so here in the figure above, the perimeter of trapezoid. So we're doing A, B, C, D, E, that whole big trapezoid. So if it's 10 on the top, it has to be 10 on the bottom. So what I have is a 10, a 10, a 4, and a 4, which is 28, subtracting from 38 because I have to get this side. And so that'll be 10. So each of these guys will be 5. And then I have my good old 3, 4, 5. So this will be 3 and 3. And to go all the way around this perimeter would be 26. You think I should ask them on that one?
Yeah, just keep going.
Okay, now this one is hard. These two are hard. So here you had to draw a line because there's no way you would get Z. So I guess that's the big thing I'm sort of saying tonight is to draw a line. I
If you
know,
ever get stuck, just draw a line.
yeah. And
It can be tricky sometimes because they don't say, hey, draw a line here.
yeah. So then X is 30. This is Y is 20. This X is 30. So I have to put 50 in here and 50 in here to make this whole big triangle add up to 180. Because I would then have 50, 50. Let's see.
You'd have 160 and then the 20 in the front.
Yeah. So, and then this 20 would make up the 360. So then on the small embedded triangle, this guy, this would be a 50, this would be a 50, and Z would be an 80. And my rationale for doing this is if you get these hard ones, you'll probably only get 1 or 2 hard geometry on the test of this level. So let me just go down the line. So Ines, are you good on this one?
Yeah.
Okay, Zoe Latham,
Yeah.
Addie, just nod your head, yes, honey. Sehana
Yeah.
and Zoe Robson.
Yeah.
Okay, good. Okay, let's go down to this one because they like the hexagons. So let's dive into 8. In the figure above, A, B, C, D, E, F is a regular hexagon. And I told you they like those because they're equilateral triangles. It's hard. So all the way around it is a 2. So I have the width is 2. But I need the length to get the area of triangle ACDF. So I remember that this is going to be 120. So this is going to be a 60, because you're not going to get a 49, 51, 90 triangle. You're going to get 30, 60, 90s or 45, 45, 90s. They've stayed consistent with that. So if this is my 2x, 2 is my 2x, opposite the 30 would be 1x or 1. Opposite the 60 would be the square root of 3. And so I would have 2 of those. So 2 times 2 square roots of 3, 4 square roots of 3. So take a minute and digest that.
I guess see if any of them got that.
Well, let's,
That one was pretty hard.
it was definitely, I mean, I'm taking you to the deep water. Sehana, are you good with that one? Or
Mhm.
tell, yes, oh, good. Zoe Robson.
Yeah.
Oh, good.
And if you have a question, just say you have a question, because she can explain it probably better.
Yeah, I could go, if you're stuck on a step, which I could, again, I mean, if I had a regular class.
They love hexagons.
Yeah.
I mean, because you can make equilateral triangles out of them, and then you can make 30, 60, 90 triangles out of equilateral triangles.
Yeah,
So,
so didn't I ask? I forgot.
I don't know if you asked Anish.
Anish, are you good with that one?
Yeah.
Okay, good. And Addie,
Oh,
I probably asked her already.
oh yeah,
Okay,
she's good.
okay, last page of these. I just wanted to give you a bunch. So this one, you have to get the shaded region. So like we did with the circles, you could get the big triangle, which is 1/2 times 10 and the height is 12. The big triangle will be 60. The little triangle will be 1/2 times 6 times 12 or 36. You subtract that and you'll get 24 for the unshaded.
For the shade.
For the shaded, I'm sorry. Yeah, the unshaded would be the 36. Or I could do each of these triangles because 1/2 the base, which the base of this is 2, and the height is 12, because remember, in an obtuse triangle, the altitude has to be outside the base, or, yeah. So either way, you would get 24. And
We're calling this one the challenge question.
we're calling this a challenge one. I promise you,
Did anybody get it on their own? I'm just curious. That's probably the hardest one.
they probably didn't get this far, baby.
Um,
Okay. Well, let's dive into it because this is the bright group. See if you can stay with me. Maybe I'll get a different color just to make.
right.
All right. So
A lot of this is realizing that you have that isosceles triangle.
the whole square, AD is 1, so this is 1. So I'm going to focus on this triangle here. So we know that this is 1 all the way
So you're
across.
trying, you need to get EC because that's the same as EF.
Yes.
Okay. That's the isosceles.
So if
form.
I get EC, then I could get EF. Cause,
And BH is gonna equal BF, cause it's a square.
Yeah.
So,
so
yeah.
first let's plunge through the Pythagorean theorem on this one. So that'll be 1 squared plus 1/2 squared equals this hypotenuse. Because we need that, we need EC to find FE. So that'll be 1 plus 1/2 squared is 1/4. So I take the square root of 5/4, I take the square root of the numerator, or the square root of the denominator, which is the square root of 5/2. And then I'm trying to get BH, but BH, let me erase this bloody red triangle. Okay, so we're trying to get BH, which is the same as FB. So to get, I just take FE, which is the square root of 5/2 minus 1/2, and that will equal BH, which is going to be answer choice
See.
C. Okay, I'm not even going to ask you if you get that.
It's a challenge question.
It's just a
It's probably,
challenge.
probably a little harder than the SAT, really.
Yeah, harder than the SAT for sure. Okay, so let's move into our trig. So the good news is,
I wanna clarify something, because you're about to cross off a lot of this stuff. It's still on the ACT.
I know.
So just make sure you tell Zoe that.
So Zoe, who's taking the ACT, for the SAT, you won't need these guys. But for the ACT, you will. And they're just inverted. Have you had exposure to this, Zoe Robson? I think you've all seen the SOHCAHTOA, right? Crickets. Okay, Zoe Robinson, have you seen this?
Yeah.
Okay. So let's go on. And so what I'd like you to do is just fill in these three with this triangle.
I guess just realize you can invert them to get the
Yeah, I
their identities.
To get the other identity.
if you need
just-
them.
You don't have to
You'll need them
know.
in your other math classes, but not on the SAT.
Okay, so I'm hoping your values match mine here. And these would just be inverted if you had them on the, you know, the ACT. Okay, so let's go to some book problems. Whoops. So everybody, I'm sure, is okay with this. It's all based on SOHCAHTOA, which they don't give you. But I'm assuming this group is so bright that I don't have to break it down. So let's try a couple book ones. We're getting done with math, I promise. So we're gonna go to an easy one, 298, number 12.
Oh, you did that one.
Oh, thank you.
Yeah.
Okay, let's try 345, number 19. Oh, and we're in module 1, so. So 24 squared is what?
576. And 51 squared is 2601. And you subtract them, you get 2025.
Yeah, and then the square root of
Square
that.
root of that is 45.
Doesn't seem right.
No, that's right. This is 45.
What are we dividing by 3, I think.
Yeah, I think you're right.
Okay, Zoe Robson, did you get 15 over 17?
Yes.
Oh, good. It's like landing and never mind.
Gold medals.
Gold medals.
Gold medals all around.
Yeah. Sehana,
Yep.
Zoe Latham,
Yeah.
Anish.
Yeah.
Good. And can you move it for
Oh, yeah, sorry. Addie's right there.
Addie? Is that good for you, hun? Okay, good. I'm giving you some hard ones. And let's do one more. This one isn't so bad. It looks, you just have to keep everything straight.
You put an L over there. Okay.
Okay. Okay, I'm assuming everybody got B for this one. Let me just ask. Zoe Robson, did you get B?
Yeah.
Good. Sehana?
Yeah.
It's like I'm asking them to do backflips and they're doing them. Zoe Latham
Yeah.
and Anish
Yeah.
and Addie. And that's going to bring us to our one identity they could sometimes test you on, which you can sort of see here. We're going to do it again. The only other identity besides SOHCAHTOA on the SAT. So you have to know this, and you also have to know, well, it's good to know the sine of theta equals the cosine of 90 minus theta, which is the other acute angle, which makes sense when we just did it on this problem. So let's go back to
Can you write that out the other way too? so
Oh,
they can
yeah.
See it?
oh, it could also be this, cosine, one acute angle equals either the sine or the cosine of the other acute angle.
And instead of 90, you might see that as pi over 2
Yeah,
in radians.
yeah,
I wouldn't worry about writing it out, but
because 90 degrees is pi over 2.
right.
So let's go back to the packet and we're gonna do another one like this. Like we just did in the book. And like
So
I
it's pretty
said,
much just that and SOHCAHTOA, that's all you need, right?
that's all you need. So here, the cosine of 23. Okay, so we know what that's gonna be. That's gonna be adjacent over hypotenuse. And that's gonna equal the other angle, which is the sine of 67. Because that'll be the opposite, which is AB over AC. So does that make sense, Anish, to you?
Yeah.
Okay, good. Zoe Latham
Yeah.
and Sehana,
Yep.
Zoe Robson,
Yeah.
and Addie, you're good? We're coming to the end of math, don't you worry. I know Zoe Robson has to leave, but well, okay, so let's do this one. A right triangle. We know that this has to be the big hypotenuse. Because that has to be our C. What's the cosine of the angle opposite the 35 side? So the cosine right here will be adjacent over hypotenuse, which will be 12 over 37. Okay. I think we're good with that. I'm just checking and see. We should do one more, but I think we're good. Yeah. Okay, so let's go on to the next page in the packet. Whoops.
Oh, so,
Oh, we don't need,
could still be on the ACT, this type of question, but SAT people, don't worry about it.
yeah,
Yeah, and don't worry about this SAT people, but it could be on the ACT, this plane landing.
yeah,
And inverse trig is on the ACT,
yes,
but not on SAT.
ACT, but
Yeah,
not
not
on
on SAT.
SAT. And we're gonna do a special session with you. Zoe Robson, you're my ACT person, right? No.
Yeah.
Okay, so we're gonna do, before you take the ACT in September, we're gonna do a special session on what was not on the SAT math that's on the ACT math. Because I know you have to get a point more. So the rest of us don't have to worry about inverse. You probably had it in school. All these nice figures Jim drew of kites and stuff, you don't need it. And so also, solid geometry, we need to go to this. This is our last thing. Okay. So they give you the formula for the volume, which is pretty easy, pi r squared h. And they give you the formula for a cone and a sphere, but they do not give you any surface area formulas. But it's not so bad because you can see, like here, there's 6 faces to a cube. So, and then it would be 1, 2, 3, 4, 5, whatever am I doing, in the back, which should be 6. So anyway, we would, for this one, we would have 6s squared is 54. S squared is 9. So each side of this cube is 3. So the volume would be 3 times 3 times 3, or 27. And so let's go, like I said, we're almost done. let's go to 418, number 5 in the book. You guys are troopers. What did I say, 418?
Number 5.
So try this one, it's not so bad. Ah. Due to my cube. It's messing me up here. It's 41. So we're just gonna do 41 cubed. Everybody get D. 68,921. And that's not so bad, because that's volume. So I'm assuming everybody got that one. So let's, because that's not so bad. So let's go back to the packet. If anybody has a question, just shout it out. And if Zoe, you have to leave early for your commitment, we're fine with that, okay, hon? We're just finishing up this last part.
I can probably stay for the rest of the math.
Yeah, it's not so bad. We just have a little bit more. So let's look at this one. A unique situation. We have a square label. All the sides are 8. And so it's a, let's say it's a soup label and I take it off a soup can. So it was wrapped around a right cylindrical can. So, Anish, let me ask you this. The bottom of the soup label will equal the what of the can, of the cylinder. Do you see the connection here?
Yeah.
Okay, so what would it be?
The area of the circle, so pi r square.
No, this 8 is going to be 2 pi r. It's going to be the circumference of the circle.
Oh, yeah.
Okay,
So,
so we're going to do 8 is 2 pi r. We are going to try to get the area. This is a hard one. So 8 over 2 pi would equal r, which would equal 4 over pi times 4 over pi. And so pi r squared would give us 16 pi. And so that one's not so bad. And so this one, if they give you, like we have a freezer here, and it's 8 by 4 by 6, and I'm putting in little ice cubes that are 2 by 2 by 2. So they could give you cereal boxes or CDs. So we're doing the big volume divided by the little volume, the 2 by 2, the ice cube. And so that'll be 8 times 4 times 6 divided by 2 times 2 times 2. And so I could nicely fit in 24 ice cubes in this freezer compartment.
Wait, this, I gotta stop you here because this one's wrong. That one's D.
Oh, I'm sorry, I circled the wrong answer. Yeah, it's 16 over pi. I had it right here. See, I need my save.
I step away for 2 seconds,
I know.
then you get the bronze.
I get the bronze. Okay. All right, let's move on. Now, they haven't asked this.
Oh, yeah. Yeah, we haven't seen this on the SAT in years, but this is like if you held a Rubik's Cube on its diagonals and you wanted to measure that distance, that you just take the Pythagorean theorem twice, but
Yeah,
we don't,
let me
yeah.
just show you this. So this would be a 3, 4, 5 triangle. I don't think they had this up their sleeves.
Yeah, we haven't seen this in a while.
And this would be a 3,
They used to test it, but
yeah,
it's been a while.
yeah. So we're not gonna worry about
Yeah,
it.
just skip it.
Yeah, let's just skip it.
But if you ever wanted to know that's how you do it, you just do the Pythagorean theorem twice.
Okay, so now we're on 4. We're not gonna do 6. They sent us a bunch of questions way back in 2016 when they changed the test to the Common Core. And they had problems like this, but none of those have appeared. So we're gonna do this crazy figure. We're doing surface area. Okay, so let's see if we can see this one and the next one, and we're done, guys, and you can have a break. So let's say if this is, so we know each edge is 5. And so we have 4 sides that are going to be 25. Do you see that?
So it's A or B already. We know it's A or B.
Yeah, because there's one side here, one on the back side, and one on the bottom. So we know we're going to have 100. Plus, we're going to have 8 of these equilateral triangles because they're 5, 5, 5. So this will be 2.5. And so we have to get the altitude, but we know there's only one triangle where the side is 1/2 of the other side. So this height of this triangle is going to be 5/2 times the square root of 3. So the area of one of these.
So you just made 2 30, 60, 90 triangles out of that?
Yeah,
Okay.
so these are all 30, 60, 90 triangles. So we're gonna do 1/2 times the base, the whole base is 5. The height is 5/2 square root of 3. And then we have 8 faces to make
So
every,
you have, so 25 over 4 square roots of 3, and you have 8 of those.
yeah. So I have 8 times 25 over 4,
Square root of 3.
yeah.
Yeah.
So that'll be 50 square root of 3, so the answer, I don't know if you're gonna get one that hard.
Yeah, just in case.
Let me see if anybody sees that. Inesh, do you see that? Sort of?
Yeah.
Okay, Zoe Latham,
Yeah.
you see it? Oh, good. Sehana?
Mm-hmm.
Oh, good. Zoe Robson
Yeah.
and Addie. I got the cream of the crop with this group. Oh my gosh. Okay, last problem for me, because we're not gonna do this bolt. So do you see this is a cylinder? And this is a cone, and that's a cone. So they give you the formula for a cylinder. That's gonna be pi r squared h. That's on the formula page. And then we're gonna do 2 cones. Each one is 1/3 pi r squared h, and that's on the formula page. So okay, the whole thing equals 90
Can you
pi.
write those 2/3? I'm just worried they might think that's 2 and a third.
Oh, sure, that's
Just-
gonna be 2/3.
Yeah.
Yeah, I'm sorry.
Right. Okay. 90 pi, right?
Yes. Putting these all in. So,
Oh, and you know all the H's. The H's are all 18.
so let's divide everything by pi, get the pi's out of there. And then all the h's are 18. The whole trick was seeing that, like there was one on the actual SAT where they had a grain silo that was sort of like this. Okay, 18 r squared plus, we're gonna put 18 in for this height.
But you have 2/3 of the one.
I
Yeah.
know. So 2/3 of 18 would be 12.
Mhm. That looks good to me.
So then I'll get 30r squared equals 90 divide by 30. So if r squared is 3, r is going to be the square root of 3. Thank you, College Board, for 10 points.
You just write down the answer this way, and just in case they wanted to try it, I'll give it to you. The bulk one.
Yes.
188.2. If you want to try a real hard one,
Yeah, but
that's.
you're
what
not
that
going to
is.
see one. They sent us that problem. We thought, what are
They
they doing?
sort of threatened that we're gonna be ones that hard, but they're not.
Yeah. So
Okay,
thanks for
so-
being such a great group,
All right,
and
so let me tell you what time it is.
we're going to take a break until what?
It is 7:24 now,
Yeah.
so let's say back at 7:30.
Okay, so get a drink or use the restroom, and we'll see you next week, Zoe Robson. Okay.
Thank you.
You're so welcome, hon. Okay.
All right, so we should be back from break now, so we're going to be doing the information and ideas packet. So find that. It looks like this. And I guess I'll just ask the group, can you just let me know that you're back?
I'm back. I'm
I'm
back.
back.
Oh, Zoe's back. I think our other Zoe had to do something, so
I'm back.
Dinesh is back. All right. And everyone is here, I think. Okay. So we're going to be doing information and ideas. This is reading comprehension. So we're going to look at central ideas and details. We're going to look at command of evidence questions. We're going to look at informational graphics and inference questions today. So this should all help boost your English score. This is 26% of the test, actually, what we're going to be doing today. All right. So these questions are all over the test. This is a good chunk of your reading and writing score. All right, so I'm just going to read about this a little bit. So information and ideas questions are on the digital SAT. They're mainly testing you on reading comprehension with these. You may have to read a paragraph. You may have to read a paragraph and a graph or chart, some kind of infographic. All right, so these are the topics. It could be an excerpt from literature. So these include novels, short stories, plays, and poetry. You might see part of a play on the SAT now. They didn't used to, but I think in the blue book, this blue book, if you look in here on one of the tests, there is an excerpt from Ibsen. I forget what play. I don't know if it was Doll's House or whatever, but plays are fair game. Poetry is fair game now too on the SAT. I think because poems can be quite short. I mean, they're not going to give you the Iliad or some long epic poem, but they might give you a few stanzas of, a poem. So those are all on the test now. The passage could be historical in nature. It could be something that you might see in a social studies class. Maybe from the humanities or science passages. And the science passages typically have graphs or charts. Maybe you'll get a bar graph, or maybe you'll get a line graph and some kind of experiment. And we're going to go over the three main types of questions for the information and ideas. There are central ideas and details questions. There are command of evidence questions, and there are inferences questions. So we're just going to start with central ideas and details. So they can test you on main ideas, which is what our first example is here, but they can also test you on details. But we'll look at a main idea question first. And you can sort of see, you'll know it's a main idea question because they'll ask you that. So here we have an example, and try it. Don't look at the answer yet. Just give this one a real try. So read about the Industrial Revolution here, and they want a main idea for this passage. And a nice thing that something you can think of about main ideas, at the paragraph level, we have a term for them. We call them topic sentences. So see which answer choice A, B, C, or D you think would make a good topic sentence that you could probably put at the beginning of this paragraph, if that's a helpful way to think about this type of question. So give it a try, and we'll go over it in a minute. All right, I'm gonna assume that everyone had a chance to try this question. So we're trying to differentiate between details and the main idea. The main idea answers the question, okay, what is this paragraph mainly about? And the wrong answer may be a detail. So it may be something true from the paragraph, but just not, it's not the big picture, it's just a detail. So I'm going to try to differentiate, and if it's a detail, I'm going to label it. So I'm just going to consider some answer choices. Here's answer choice A. Mechanized farming methods vastly improved the efficiency of agriculture in the 19th century, leading to a reduced farming workforce. All right, is that in the passage? Sure, it's right here. So there's mechanization in farming. Is that the main idea of the entire paragraph, however? And it's not. That's a detail. But we're looking for the main idea, not a detail. And cross it off. Okay. What about C? The textile industry soon dominated Europe and the US as automated looms produced the vast majority of fabric that had once been hand woven. Is that in our passage? Sure, it's right here. So the passage does mention the textile industry. Is that the main idea of the passage, or is that a detail? It's detail. We wanted the main idea, not a detail. The boom of the textile industry led to over 1,200 cotton factories and 1,500 woolen factories. That is in the passage. It's right there. That's a detail. But this is the topic sentence of the paragraph, right here. If I took this sentence, the one I'm about to read, I could put it right at the start of this passage, and it would make perfect sense right here, because this explains what the entire paragraph is about. One of the most profound effects of the Industrial Revolution was the mass movement away from an agrarian focus, a farming focus, and rural setting to a manufacturing interest and urban setting. So that's the main idea of this paragraph. So try not to get distracted by details when they're asking you for the main idea. So that was a good one to start with. But they also will test you on detail. Sometimes you need a detail. So we're going to read about the Homo habilis here. Looks like we have a science passage. And they ask us a question about a detail from within the passage. I'm going to read what they ask us. They say, what does the text most strongly suggest about tool use with regard to Homo habilis? So give this one a shot. Try not to look at the answer. Maybe I'll just read it. We can just do this one together. All right. Homo habilis had a larger brain case than the older hominid Paranthropus robustus, and its corresponding greater intelligence may have allowed it to make the jump to solving problems using tools. Unlike Paranthropus robustus, which had a large cranial ridge to support the muscles needed to crunch through tough food, as well as massive teeth and jaws, the features of Homo habilis were relatively delicate. It is thought that the use of stone tools to process food allowed Homo habilis to rely less on its teeth and gradually lose these robust features. This transition continued all the way to the anatomically modern human, Homo sapiens. So I'm just going to consider some answer choices, and we just have to figure out, okay, what does the text strongly suggest about tool use with regard to Homo habilis? Let's consider A. If Homo habilis would have had a smaller brain case, then modern humans may not have existed in their current form. So, first of all, answer choice A sounds extremely hypothetical. So that's a red flag. But more importantly, the passage just never makes this claim. This is a baseless claim. The passage never says that, this statement or anything, to that effect. So I'm gonna cross it off. All right, what about answer choice C? Paranthropus robustus shared many traits in common with Homo habilis. Is that the point of this paragraph? Is the point of this paragraph how similar these hominids are? They're very different, right? So Paranthropus robustus has a large cranial ridge to support muscles that are needed to chew through food. Homo habilis has delicate features, so they're very different. The point of this passage isn't their similarities. The point of this passage, I think, pertains more to the difference between these two hominids. All right, answer choice D. Many types of hominids have developed tool use. That may be a true statement. I'm not an evolutionary biologist, but that could be a true statement. However, this is not in the passage. All right. We can cross it off. It's just not in the passage. So if it's not, if it's, you just look at the evidence that they provide you, and you may say to yourself, you know, you've taken biology classes before. You may think that this is a true statement. It sounds like that might be a true statement to me, but we just have to go with what's in the passage, and the passage does not make that claim. The passage does, however, argue this: tool use played a key role in the transition from mankind's ancestors to modern humans. So Homo habilis was able to use tools, and Paranthropus robustus was not. Paranthropus robustus had massive teeth, massive jaws, a large cranial ridge to support these muscles. Homo habilis has delicate features. So, I mean, you can just think about this as a thought experiment, because they say that this trend continued all the way to anatomically modern humans. So, could you eat a caribou without tools or without fire? Probably not. You probably would break your face, right? So, tool use played a key role in the transition from mankind's ancestors to modern humans, and the descendants had relatively more delicate. Sorry, I'm getting tongue-tied here today. The mankind's ancestors, all the way to anatomically modern humans, they have more delicate features compared to the robust features of Paranthropus. Okay, so that one was B. So that they could ask you about a detail. That was a detail from that passage. Next is a command of evidence question. Okay, so they could test you on evidence from a text, or they could test you on evidence from an infographic. We'll look at a text-based one first, but we'll look at an example with an infographic. So let's take a look at a text-based question. So it looks like we have a novel here, David Copperfield. Okay, and I know some people taking the SAT, they'll say to themselves, oh, they expect me to have read David Copperfield? I never read this. Relax. All we need is just these few short quotations from the novel. We're just gonna look at the quotes that they provide from David Copperfield, and we're going to support a claim. So, all right. And you can actually you can trust that these are all quotes from David Copperfield. They're not trying to trick you in some way by throwing in some quote that isn't from the novel. We can assume that these are all in the book. All right, so I'm going to read the question, and then we're going to pick the quote that supports the claim. All right. So in the novel, Dickens describes James Steerforth's propensity to condescend in his behavior toward others, as is evident in his interactions at Salem House boarding school. Okay, so I'm going to take, and on the digital SAT, you can highlight or underline portions of the question. And I would recommend that you do that, because I'm gonna underline, or actually I'm gonna highlight the claims right here. This is what we're looking for in a quote. We want some evidence that Steerforth condescends. Steerforth patronizes people. That's just the claim. And on the ACT, you can underline, if you're taking the paper ACT, you can underline portions of the question, same thing, and they will have evidence-based questions on that test as well. All right, so if it seems like I have a quote here that shows that Steerforth is being condescending, that's the right answer. If it doesn't seem condescending, we're just going to cross it off. All right, but the greatest wonder that I heard of Mr. Creakle was there being one boy in the school on whom he never ventured to lay a hand, and that boy being J. Steerforth. All right, so I don't see anything patronizing. I don't see any condescension. I'm going to cross it off. I heard that Miss Creakle was regarded by the school in general as being in love with Steerforth, and I am sure as I sat in the dark thinking of his nice voice and his fine face and his easy manner and his curling hair, I thought it very likely. All right, I don't see anything condescending. I'm going to cross it off. What about answer choice D? Steerforth continued his protection of me and proved a very useful friend, since nobody dared to annoy one whom he honored with his countenance. I don't see anything condescending in answer choice D. Let's look at C. In this, I was much assisted by Mr. Mell, who had a liking for me that I am grateful to remember. It always gave me pain to observe that Steerforth treated him with systematic disparagement. That's the right answer. So there it is. And seldom lost an occasion of wounding his feelings or inducing others to do so. All right, so that shows a little bit about Steerforth's behavior. Answer choice C, which is what we were looking for. The other questions don't mention his behavior. All right, now we have a quantitative evidence example. So there are reading comprehension questions that utilize a graph or a chart. Here we have a line graph. And always read, they always give you the title of the figure, so always read it. This is what the figure is going to show. It's going to show percent errors made for line length comparison for 1 to 15 Confederates. It looks like I have percent errors on the y-axis right there, and it looks like I have number of Confederates on the x-axis. All right, so I'm going to read the experiment and then see if you can figure out what the graph shows. They just ask us which conclusion can be drawn from the graph. All right, here's the experiment. An experiment was performed in which one participant was the actual subject of the experiment. The subject was placed within a group of one or more other participants who were Confederates. They were in league with the experimenter, and their answers were carefully scripted. The true subject was unaware of this fact. The participants were shown one vertical line on a card, followed by another card with 3 lines labeled A, B, and C. One of these lines was equal in length to that of the first card, and the other 2 lines were obviously longer or shorter. Each participant was asked to state the letter name of the line that matched the first line in length. The participants were seated so that the real subject always responded last. On the first 2 trials, the Confederates unanimously chose the correct line, but in all subsequent trials, they would unanimously select the same incorrect line. There were 15 trials in total. The experiment is repeated with different subjects and incrementally larger numbers of Confederates, from 1 to 15 in total. The graph above displays the percentage errors the subjects made with the corresponding number of Confederates present. Which conclusion can be drawn from the graph? All right, so I'm going to look at the answer choices. Try not to, don't look at the answer on the next page yet. Let's see if we can see what the graph shows. All right, does the figure show that subjects erred less when presented with a greater number of Confederates? No. No. So I'm just looking at the graph. Looks like more Confederates. We have more errors, and it tops out right around 35% or so. So they erred more with more Confederates present. All right, let's look at the next one. The number of Confederates had no effect on the percentage of errors the subjects made. Well, they're definitely correlated. The more Confederates you have shouting out the wrong answer, the more these subjects are getting the question wrong. So it's not B, no. All right, the percentage of errors the subjects made increased with each additional Confederate. Is that what our graph looks like? That would be a straight line going with a positive slope, be like this. And we don't have that. The problem with this answer are these words, each additional Confederate. But that's not the case. It looks like it tops out. It looks like once you have 4 Confederates, you just have around a 35% chance of an error. Last one, subjects erred when presented with a group of 4 Confederates as readily as they did to a larger group, and that is true. It looks like once we get to 4, they are just as likely to answer incorrectly. All right. So they can test you with a figure. Inferences. So next we're going to look at inference questions. Inference questions require you to understand what a passage strongly implies to draw rational assertions regarding the text. All right, so we're going to read here, and we have to figure out which answer choice finishes the passage. One of these statements we would logically expect to be present in this paragraph, and not the others. All right, so I'm going to read this. Here's an inferences question. In 1895, German physicist Wilhelm Röntgen discovered and named the X-ray. He was experimenting with various vacuum tubes by passing electrical charges through them. Even though the vacuum tube he was using was shielded by cardboard, a screen 9 feet away suddenly changed another color. He hypothesized correctly that this occurrence must have been caused by an unknown ray, not knowing what blank. So we have to finish the last statement. And I'm going to go through some answer choices. And if it doesn't sound like it logically follows, if it's a valid inference, I'm going to cross it off. All right. I'm just going to start with C and D. Consider C. Not knowing what could have caused this phenomenon, more study would be necessary. C is the wrong answer because it implies that Röntgen didn't know what caused the screen changing color. He did know what caused it. He believed it was caused by a ray. So C assumes that he doesn't know what caused this, but he did. It was an unknown ray. So C is out. He did have a theory about what caused the phenomenon. He thought it was an unknown ray. All right, let's look at D. Not knowing what happened, Röntgen would later use it to reveal the bone structure of his wife's hand. D implies that he didn't know what was going on, but he did know what was going on. He knew it was caused by an unknown ray. All right, that one is out. So really, we just have it down to answer choice A or B. Not knowing what to call it, many of his colleagues suggested calling them Röntgen rays. That's an option. Or answer choice A, not knowing what type of ray it was, Röntgen called it X to designate it as an unknown type of radiation. That is the correct answer. And really, if you just read the first sentence of this paragraph, you would know that's the right answer. Right here. German physicist Wilhelm Röntgen discovered and named the X-ray. So we know it's an X-ray. They still call them X-rays. This, if you weren't paying attention, maybe you missed this named part. But because that's there, I know it's answer choice A and not B. We know that his colleagues didn't name it. We know that Röntgen did. All right, on to the next question. All right, so I have a question here. It looks like it's another experiment. I have some data. Give this one a try. I'm just gonna leave this up here for a minute or two. Try number one, lock in on an answer, see if you can use this chart and read about this experiment and select an answer. Just give it a try. Take a couple minutes. Give this one a go. All right, I'm gonna assume that everyone had a chance to try this one. All right. So I'm gonna read the question and then they ask us for evidence that supports the researcher's conclusion. All right, so we have a table, relative duration of gaze of infants at 6 stimulus objects. Looks like we have face, bullseye, news, white, yellow, and red. All right, and then we have just the ages of the infants. All right, so I am going to, and then it's mean percentage of fixation time is what the data shows. All right, psychologist Robert Alphonse and colleagues conducted an experiment in which 18 infants from 10 hours to 6 months old were placed in a crib on their backs to view a series of 6 images in random order from 1 foot away. The 6 images were all circular in shape, 6 inches in diameter and non-glossy. 3 images contained black and white patterns, an illustrated face, a bullseye, and newsprint. 3 images contained plain colors, white, yellow, and red. The researchers recorded the duration of each infant's gaze on the images by monitoring the reflection of the target image in the infant's eyes. Based on analysis of the relative duration of fixation time of the infants, the researchers concluded that infants across all age groups showed significantly greater visual attention to patterned surfaces in comparison to plainly colored surfaces. All right, which choice uses data from the table to most effectively support the researcher's claim? Well, we're allowed to highlight or underline portions of the question with the Blue Book software. So I'm going to do it. And I suggest that you do the same when you're taking the test. I want to support the claim that I have to support. I want to underline or highlight the claim that I have to support with evidence. It's this. Here's the researcher's conclusion. Infants across all age groups showed significantly greater visual attention to patterned surfaces in comparison to plainly colored surfaces. That's what we're trying to support. All right, let's look at answer choice A. Infants from 2 to 6 months old had a mean percentage fixation time of 8.2 on the yellow colored surface in comparison to 10.1 on the red colored surface. So I only have plainly colored surfaces here. That is the incorrect answer. I need a comparison. I need data that shows that they spent more time fixated on patterned surfaces. So A is out. It's only plain colors. B, infants from 2 to 5 days old had a mean percentage fixation time of 9.9 on the white colored surface in comparison to 6.7 on the red colored surface. Again, I only have plainly colored surfaces. So it's not the right answer. I want a comparison of patterned surfaces to plain surfaces. Infants under 48 hours old had a mean percentage fixation time of 12.3 on the white colored surface in comparison to 11.5 on the yellow colored surface. So we're comparing white and yellow. We are only comparing the plain colored surfaces. So it's not C, but look at D. Infants from 2 to 5 days old had a mean percentage fixation time of 29.5 on the face, which is a pattern surface, in comparison to 9.9. Oop, I didn't want to cross it off. I wanted to circle it. 9.9 on the white colored surface. So here we have, they're spending approximately 3 times the duration on the pattern surface in comparison to the plainly colored surface. So that is the right answer. That's what we were looking for. And just in general, if the data shows, I don't know, something to be 3 times greater than the other, that is strong evidence. It's not like a slight difference. Like some of these, oh, okay, I'm just looking at like the white, maybe look at yellow and red. Okay, they're only like one apart. But look at the difference between this and these. Significantly greater. And then those are some of our highest numbers, or we have a higher one there, but yeah, it's like 3 times as much. So they're looking at pattern surfaces much longer. All right. So, all right, so we tried that one. All right, I want you to try the rest of them. So it looks like we have just 5. So try number 2. I'm gonna give you guys a little bit of time to try the rest of these. So, take about 5 minutes, try the rest of these. And then we're gonna do some from the blue book, and then that's pretty much all we're gonna have time for tonight. So give these ones a try, and we'll go over them in a little bit. Okay, it's been about 5 minutes, so I'm just gonna ask the group if you had a chance to try them all. Sahana, did you get a chance to do all these?
Yeah.
Okay, so I'm gonna assume then that everyone had enough time. Thank you. All right, so let's look at these. And grade them as you go. I do think it's important to keep track of how many we got correct. I'm gonna maybe make a note of that here so I remember to at the end. Add them up. All right, so back to number 2 where we left off. So it's a main idea question. So always think main idea versus detail. If it's just minutia, if it's something that seems just like a detail, that's not what we're looking for. That's the wrong answer, even if it's true. All right, I'm going to read the question. Since 1995, physicists have been able to cool atoms down to billionths of a degree above absolute zero to create a single quantum state called a Bose-Einstein condensate. Since then, physicists have desired to create Bose-Einstein condensates out of molecules, and recently they have succeeded. Molecules are more intricate than atoms and interact with one another in different ways. This new development could lead to a revolution in quantum computing. All right. So we're looking for the main idea. If it seems like a detail, I'm going to cross it off. All right, let's look at answer choice A. Molecules are more complex than atoms and interact differently than atoms. That is a detail. That's not the main idea of this passage. I can cross it off. C, creating Bose-Einstein condensates requiring cooling substances to near absolute zero. That's a detail. It's a true statement. It's in the passage, but it's not the main idea of the passage. We're looking for broad strokes. We're looking for the big picture here. Scientists have created Bose-Einstein condensates out of atoms since 1995. That's detail. It's true, but it's just a detail. Now, what the passage is mainly about is answer choice B. This is what we care about. This is the big picture, the main idea. Scientists have now created Bose-Einstein condensates out of molecules rather than atoms. That is the important development here. So we know that they've been able to make Bose-Einstein condensates from atoms for a long time, but recently they can make them out of molecules. Molecules are more interesting. You can do more with molecules than you can with atoms. That's a more complex thing. So that's the point of this passage. Answer choice B. That's the main idea. All right, on to number 3. It looks like we have an excerpt from a novel. Whoa, I didn't mean to zoom in on it to that extent. All right, so I'm going to read this little excerpt. It looks like this is from Edith Wharton's Age of Innocence. And they don't expect you to have read this novel. This book is probably 400 or 500 pages long. We don't need it. All we need is this much of it right here. So I'm going to read it. In addition to the forest of family trees, Mr. Sillerton Jackson carried between his narrow, hollow temples and under his soft thatch of silver hair a register of most of the scandals and mysteries that had smoldered under the unruffled surface of New York society within the last 50 years. So far, indeed, did his information extend, and so acutely retentive was his memory, that he was supposed to be the only man who could have told you who Julius Beaufort, the banker, really was, and what had become of handsome Bob Spicer, old Mrs. Manson Mingott's father, who had disappeared so mysteriously with a large sum of trust money less than a year after his marriage, on the very day that a beautiful Spanish dancer who had been delighting thronged audiences in the old opera house on the Battery had taken ship for Cuba. But these mysteries and many others were closely locked in Mr. Jackson's breast, for not only did his keen sense of honor forbid his reporting anything privately imparted, but he was fully aware that his reputation for discretion increased his opportunities of finding out what he wanted to know. Based on the text, how do members of New York society most likely regard Mr. Sillerton Jackson? Answer choice A, most dislike him for his propensity to gossip. That's not in the passage. I can cross it off. Some view his tales to be greatly exaggerated. That's not in the passage. I can cross it off. Many believe he is lacking in moral character. There's no mention of that in the passage. However, there is evidence to support answer choice D. Few would fear that he would divulge their secrets. That part is right here. These mysteries and many others were closely locked in Mr. Jackson's breast. He had a reputation for discretion. All right. Just a little bit of reading comprehension. All right. So the Blue Book software allows you to underline portions of the question. I suggest that you do this. And on the AC2, you can underline portions of the question. So use the software to your advantage. I'm going to underline the thing we're looking for. We're looking for this. It's just going to make it easier to find when I'm looking at the quotes. All right, which quotation from an art critic best supports that part that I just underlined? Let's look at answer choice A. Many African Americans who traveled to, I'm looking for folk art. Many African Americans who traveled to Europe. Actually, maybe I should read this whole question just so, be consistent here. William Henry Johnson was a prolific African American painter who produced works in the US and in Europe. In an essay about Johnson's work, a student claims that later in his career, Johnson developed a simplistic style influenced by folk art. All right, answer choice A. Many African Americans who traveled to Europe returned with new perspectives. Johnson, who had 2 long episodes abroad, was no different. There's no mention of folk art there. I can cross it off. European influences on Johnson's early work were many. He was clearly influenced by post-impressionists, including Van Gogh. I wouldn't claim that Van Gogh is folk art. I'm going to cross it off. Answer choice D. Following the death of his wife, Johnson's physical and mental health deteriorated and he was institutionalized. He ceased to paint after 1955. There's no mention of folk art in answer choice D. Let's look at C. This period saw a marked change from his earlier modernist and expressionist influences. He drew on his rural Southern upbringing and naive figures of African American traditionalism would dominate his canvases. So there's the folk art. That was what we were looking for. That was our claim. On to number 5. Looks like we have an excerpt from a short story, Bartleby the Scrivener. Oh, by Melville. So all we need of this short story is this. We just need a paragraph. They don't expect you to have read this before. We just have to read this and we have to say something that is true about the narrator. All right, here is the excerpt. I am a man who, from his youth upwards, has been filled with a profound conviction that the easiest way of life is the best. Hence, though I belong to a profession proverbially energetic and nervous, even to turbulence, at times, yet nothing of that sort have I ever suffered to invade my peace. I am one of those unambitious lawyers who never addresses a jury or in any way draws down public applause, but in the cool tranquility of a snug retreat do a snug business among rich men's bonds and mortgages and title deeds. All who know me consider me an eminently safe man. All right, so I'm going to look at my answer choices, see if it supports something true about the narrator. If it doesn't, I'm just going to cross it off. All right, answer choice A. He wishes he could attain public prestige by presenting more important cases before a jury. So the story never makes that claim. I'm going to cross it off. He suffers from not being well compensated for his services. That's not true. He does a snug business. That's right there. So I'm going to cross off B. He makes money. All right. Let's look at D. He, like most lawyers, inhabits a career that is fast-paced and anxiety-inducing. Well, he says the profession is proverbially energetic and nervous, but does that affect him? No. He never suffers it to invade his peace, which is answer choice C. He is content with the ease and efficiency of his chosen path. Right here, here's the evidence. The easiest way of life is the best. So that supports C. That's true of our narrator. So add up how many you got right out of 5. Let's say I got 4 of them right. I'd put that there. actually write it down on your packet. I know we did the first one together, that's like a free space. But I think it's important to keep track of these as we do them, just to be honest and, okay, am I getting all of these correct? Then I'm in good shape. You know, am I missing 2 or 3? Well, we gotta work on this. So I want to do some from the blue book. So I'm just gonna give you a page number. We're just gonna do some information and ideas drills. This is page 119 in the blue book. So open up your blue book, turn to this page. We're going to try some of these. All right, so it looks like on page 119, I've got 12 of these. We're not going to get a chance to do all of them tonight. We're just not going to have that kind of time. But let's say try the first 5. Oh, it's hard to write on this tablet, man. Try the first 5. I want you to do all of these at some point. Maybe tomorrow, you know, I would just for tonight, just try the first 5. Because I don't think we're going to get into the infographics. Those come in around question 7. So I want you to be really good with the graphics. So that's why I want you to try these at a later time, but just try the first 5 for tonight. We'll go over those ones. So take 5 minutes, try 5 of them. And then in 5 minutes from now, I'm going to start going over those. All right, it is 8:25, so our 5 minutes are up. If you're still working on the last problem, that's fine too, but I am going to start going over these just in the interest of time. And then we'll be done for tonight. All right, so let's look at the first one together. And just grade them as you go. If you miss it, just mark it wrong. I think it's important to keep track of that. All right. Okay, here's a question. The ice melted on a Norwegian mountain during a particularly warm summer in 2019, revealing a 1700-year-old sandal to a mountaineer looking for artifacts. The sandal would normally have degraded quickly, but it was instead well preserved for centuries by the surrounding ice. According to archaeologist Espen Finstad and his team, the sandal, like those worn by Imperial Romans, wouldn't have offered any protection from the cold in the mountains, so some kind of insulation like fabric or animal skin would have needed to be worn on the feet with the sandal. All right, so what does the text indicate about the discovery of the sandal? So I highlighted a portion of the text that showed high temperatures, and I highlighted a portion of the text that showed low temperatures for centuries, which indicates C, temperatures contributed to both protecting and revealing the sandal. Next one, we have an excerpt from a short story. All right, so how do people in the capital of Mexico most likely regard Dr. Malsufrido? All right, answer choice C. Most would be unimpressed by him were it not for his professional expertise. That's not in the passage. I can cross it off. Some dislike how freely he discusses his own family. That's not in the passage. I can cross it off. The thing that is mentioned in the passage is this, though. Family secrets do not fly out like a flock of parrots, but remain nicely bottled up beneath a dome of old and highly polished ivory, which is answer choice A. Few would feel concerned that he would divulge their confidences. On to the next one. Looks like it's a science passage. NASA's Cassini probe has detected an unusual wobble in the rotation of Mimas, Saturn's smallest moon. Using a computer model to study Mimas's gravitational interactions with Saturn and tidal forces, geophysicist Alyssa Rodin and colleagues have proposed that this wobble could be due to a liquid ocean moving beneath the moon's icy surface. The researchers believe other moons should be examined to see if they too might have oceans hidden beneath their surfaces. All right, let's look at some answer choices and select the right one. Let's look at A. Rodin and colleagues were the first to confirm that several of Saturn's moons contain hidden oceans. The incorrect part of this statement is underlined. Several of Saturn's moons, we only know about Mimas. So A is out. Research has failed to identify signs that there is an ocean hidden beneath the surface of Mimas. Actually, the research indicates that this is likely the case. Their research shows that this is plausible. So B is out. Their research shows that there may be an ocean beneath the surface. C. Rodin and colleagues created a new computer model that identifies moons with hidden oceans. The problem with this one is moons plural. Moons? Their model is limited to one moon, Mimas. Their model only works on Mimas, not moons plural, just Mimas. Research has revealed that an oddity in the rotation of Mimas could be explained by an ocean hidden beneath its surface. Bingo, right answer. Just two more. Hip-hop pedagogy is a form of teaching that's gaining popularity across school subjects. It involves incorporating hip-hop and rap music into lessons as well as using hip-hop elements when teaching other subject matters. For example, Quan Nelum's students look for college-level vocabulary and historical events in rap songs. Researchers claim that in addition to developing students' social justice awareness, hip-hop pedagogy encourages student success by raising students' interest and engagement. So this was kind of nice. They actually underlined the claim for us. So that's what we're looking for. Students tend to be more enthusiastic about rap music than they are about hip hop music. The passage never makes that claim. Educators report that they enjoy teaching courses that involve hip hop and rap music. Do we care what the educators think? No. We're looking for students' interest and engagement. I don't care if the educators enjoy this or don't. All right. Students who are highly interested in social justice issues typically don't sign up for courses that incorporate hip hop and rap music. The social justice awareness part, that's not what we were looking for. We were looking for the part that immediately followed that, the underlined portion. So it's not D, the correct choice is C. Courses that incorporate hip hop and rap music are among the courses with the highest enrollment and attendance rates by the students. And that was what we were looking for. All right, last question. Pulitzer Prize winning writer Hector Tobar has built a multifaceted career as both a journalist and an author of short stories and novels. In an essay about Tobar's work, a student claims, underline the claim, use blue book, underline it, highlight it, whatever you want to do. Tobar blends his areas of expertise by applying journalism, underline that part, to fiction, underline that part. All right, so which quotation combines journalism and fiction? Answer choice A. For one novel, an imagined account of a real person's global travels, Tobar approached the subject like a reporter, interviewing people the man had met along the way and researching the man's own writings. All right, so make sure you add up how many you got right out of 5 here. I would like you to try the rest later, just because I want you to try some of these that have graphics. Like number 7 is a hard one. So if you can do this, you're good. More graphics, more graphics. So try all the rest of them later. There are 12 total. And then once you have done all of them, add up how many you got right out of 12. If you're getting 11 out of 12, you're in the 700s. I promise you. So that's all we have for tonight. Thanks for staying on with me. If you haven't taken a practice test, SAT or ACT, please take one. That's it. That's all I've got. So we'll see you guys next Wednesday. I'm going to sign off, and I guess you guys can sign off as well. So thanks, Anesh.
Thank you.
Thank you.
Thanks, Zoe. And thank you, Addie. See you guys.